Hello, I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, James Engineering Management Technical Campus, Greater Noida. The subject that I teach in BTech 5th semester for ECE students is digital communication. This is the main subject, and the topic that I discuss today is Gaussian, or sometimes called as normal distribution. So and this Gaussian or we may say normal distribution is very much important, and many times the question asked in the examination directly from this topic, Gaussian distribution. So this distribution is important, and this distribution come in the category of continuous distribution. So we already discussed two discrete distribution also in previous video lectures, binomial distribution and Poisson distribution. But this particular distribution is a continuous distribution. So Gaussian distribution, which we called as a normal distribution. So the normal distribution is the one of the most popular and useful continuous probability distribution. This is very important line. The normal or the Gaussian distribution is the one of the most popular and useful continuous probability distribution. Why this Gaussian distribution is popular and important for the engineers, especially for communication engineers? What is the reason behind that? Actually, the reason behind is that in communication, most of the research are going on the topic noise, right? Noise play a very important role in communication engineering, right? Engineers want to eliminate this noise to get the successful communication. So various ways, various techniques are developed or should be developed by the engineers to avoid this noise, to get the useful communication system. And the noise that come in the picture in communication engineering actually follow this Gaussian distribution. This is important. So the noise in communication, which act as a random variable, because distribution of what? Probability distribution of what? Probability distribution of random variable. And random variable and randomness that come in communication come from noise. So noise considered to be a random variable, and that noise which considered to be a random variable follow Gaussian probability distribution, right? So engineers should have the knowledge of Gaussian distribution, Gaussian probability distribution, to capture this noise, to know this noise. Once you know the noise, then you have to take the measures to avoid this noise. All right. So this particular distribution is important because noise in communication follow this distribution, which you call as a Gaussian distribution, and that's why the random variable in communication, as far as noise is concerned, is a noise random variable, right? So the random variable in communication is normally a noise, and that noise follow this Gaussian distribution. That's why there is a importance of this Gaussian distribution in communication. So that topic is important for the student also, right? And we also know that each probability distribution has its own mathematical model, right? First you have a mathematical model, then after you have to draw the result. The shape of the distribution comes after you have a mathematical expression or mathematical model of that probability distribution. So if you see in this slide, the formula or the mathematical expression or the mathematical model for this Gaussian or normal distribution is this one. What is this? Fx is equals to 1 upon sigma under root 2 pi e to the power minus x minus mu square upon 2 sigma square. X is a random variable, sigma is the standard deviations, mu is the mean. These are the standard terms that are used for these normal for variance and mean, standard deviation, right? So this is the mathematical model or the mathematical expression for the Gaussian, for the random variable which follow Gaussian distribution. So x is a random variable, and that random variable follow Gaussian probability distribution function. So this is the mathematical model of that. So this Gaussian distribution or normal distribution is symmetrical with the midpoint representing the mean. What is the meaning of that? The meaning is that this at the mean, if you draw so this Gaussian distribution or a normal distribution, this normal distribution is symmetrical with the midpoint representing the mean. Means in a graph of this particular distribution, at the mean, if you draw a perpendicular, the result is divided into two parts, and these two parts are identical, right? Means the probability of a random variable is 50% about this mean, because the area that divided by the perpendicular which you draw at the mean is divided the whole area into two equal parts. That's why, because the two parts are symmetrical. Because of symmetrical, areas are equal. That we will see in a graph later. And second point is, shifting the mean does not change the shape of the distribution. Means if you shift the mean, the shape of the distribution remains the same. This can't affect the shape of the distribution. I mean, if you change the mean, position of mean, then shape of the distribution remains the same. Third, values on the x-axis are measured in the number of standard deviations away from the mean. Fourth, as the standard deviations become larger, the curve flattened. Means if you increase standard deviations, the curve is broadened or flattened. As the standard deviation becomes smaller, the curve becomes steeper. That we will see in the graph. Look at the graph of this distribution, right? It has two parts. Focus on left side part. In first picture, Look at this first picture. In first picture, this picture, mean is at the mean of this particular graph result is at 50, right? This is the mean. Now, if you shift this mean left side, means at 40, mu over 40, look at the shape. Shape is unchanged, remains the same. That we had talked about in previous slide. The shape remains the same. If you change the mean position, then shape of the distribution remains the same. And this is the example. So if you move left side, means smaller mu, then with same standard deviation, then shape remains the same. Similarly, if you move at the right side, means a large mu, if you shift this 50, this mean position 50 to 60, again the shape remains the same. This means that the position of this mean, change in position of the means can't affect the shape of this distribution, which we call as the normal distribution. And in right side, look at the right side. Means the mean is same for 3 cases, 1, 2, 3. But we change this sigma, which we have which we call as a standard deviation, and look at this. Look at this. So for a smaller sigma, look at this. This become more steeper. For small, large standard deviation, it broadened. Sorry. So what is the conclusion? What is the conclusion? Conclusion is that shift in mu doesn't change the shape, but shift in sigma, which we call as a standard deviation, change the shape. Shape becomes steeper, maybe broaden. Right? So this is the conclusion for Gaussian or normal distribution as far as the shape of the distribution is concerned. Now, if you have a normal distribution or a Gaussian distribution, and if you want to convert into a standard normal distribution, then what you have to do? Or on what basis you have to declare particular normal distribution as a standard normal distribution or Gaussian distribution? The condition is a standard normal distribution has a mean of 0 and a standard deviation of 1. Means if the Gaussian distribution has a mean at 0 and standard deviation fixed at 1, then in that condition, this normal distribution declared as standard normal distribution. Then in this case, the new standard random variable z come in the picture, and that z random variable defined as x minus mu upon sigma. Look at this expression, where x is equals to value of the random variable we want to measure, mu mean of the distribution, sigma standard deviation of the distribution, and z number of standard deviations from x to the mean mu. I once again focus on that. For example, look at this. If this is mean, this point is at mean, and look at this mean. At mean, you draw a perpendicular like that. Then what's happened? What's happened? The whole distributed area of this random variable divided into 2 parts. One part is this, second part is this. Means both have equal area because of symmetry. Look at the symmetry, same symmetry. Left side of this normal and right side of this normal have the same symmetry, means same area. So the probability of random variable, the existence of the random variable or the probability of the existence of random variable is 50% at the left side and 50% at the right side. So look at the shape. So the perpendicular that we draw at about this mean position, then the whole area, whole distribution divided into two equal parts, and two parts are symmetrical about this mean that we talk about. So the probability of the existence of a random variable, Gaussian random variable, is 50% at the left and 50% at the right. So this is the concept of that distribution. I once again say that in communication, noise is considered to be a Gaussian random variable. That's why the distribution that come in the picture is Gaussian distribution function or Gaussian distribution probability distribution, right? So this is very important. And so I just say that students should go through this particular topic, and this is the straightforward topic of your second unit as far as syllabus is concerned. So many times the questions asked in the examination about this Gaussian distribution, Gaussian random variable, right? So this is very important topic. The students should go through this particular topic, right? So this is the end of this Gaussian distribution. Sometimes question asked in normal distribution, or sometimes question asked Gaussian distribution. Please don't be confused in that, because Gaussian distribution are called as normal distribution. So Gaussian and normal distribution are same. Thank you very much.